Now let's examine ways that our samples can have bias. And in particular, we'll look at a case study from a US election. So let's look at the 1936 presidential election. In that election, Roosevelt was going up for re-election against Landon. Roosevelt was running as a Democratic candidate and Landon as a Republican. And as usual, polls were conducted to try to predict the outcome. At the time, the Literary Digest was a magazine that had been pretty reputable in previously predicting the correct presidential winner. They conducted a survey leading up to this election and sent their survey out to 10 million individuals. They found these individuals, so their sampling frame consisted of phone books, lists of magazine subscribers, and lists of country club members. So here's what happened in the actual election. Roosevelt ended up winning with 61% of the vote. But here is what the Literary Digest poll had predicted. They were way off. Not only were they wrong in predicting who was going to win, but they were off by a lot. And the question is, how could this have happened? They surveyed a huge number of people. Okay, so let's think about some things that went into this problem. The biggest red flag was that this sample was not representative of the population. The sampling frame they were using did not consist of the entire population, and in fact, it was biased because it was people in phone books, people who had subscribed to magazines or went to country clubs, and in general, that was skewed towards more affluent people, and at the time, those people tended to vote Republican. The other thing that happened was even though they sent the survey to 10 million people, only about 2.5, just less than 2.5 actually filled it out, 2.5 million. And so there's really no way of knowing how those non-respondents would have actually responded. Now, interesting story is at the same time as this Literary Digest was conducting its large poll, a rising statistician named George Gallup also conducted his own poll. He didn't have the same resources that the Literary Digest did, and so he did a much smaller sample. It was only 50,000. And he was able to correctly predict at least the winner. So his prediction showed 56% were in favor of Roosevelt, and that did lead to Roosevelt winning in his poll. Now, granted, he was still off by about 5%, which in these days is a lot of error, but it wasn't enough for his prediction to be wrong. And even better, he actually predicted what the Literary Digest outcome was going to be based on sampling people from the sample frame he guessed they were going to use. And so again, he only sampled 3,000 people, but he used the same sampling frame of phone book, magazine subscribers, country clubs, and he got a prediction of 44%, whereas the Literary Digest went out and did 10 million of these people, that same sampling frame, and had 43%. So this highlights the issue that occurs when we have bias. So let's review some common biases. The first is selection bias. So this is when you end up systematically excluding or favoring particular groups. This happened in the case of the Literary Digest poll. And so this can happen when your sampling frame is not representative of your population, or it's not exactly equal to your population, or it can happen when you use a sampling method that doesn't have random chance mechanisms to ensure that you're getting a random representation. So really protocols to help you avoid this is to make sure as much as possible that the sampling frame and the population align and that you're using very deliberate sampling methods. And we'll talk about some of these in the next video. Another common bias is response or measurement bias. And that's the fact that people don't always respond truthfully, or questions can lead people to move towards a certain type of response. So in this case, an example would be asking citizen questions on a census survey. This may lead certain people not to answer truthfully. Some ways of trying to avoid this is really to examine the nature of the questions in your survey. Sometimes you can send out pilot surveys first to help improve question wording and thus hopefully reduce measurement bias. In terms of instruments that have some measurement bias, again, you can try to do some protocols to try to calibrate the instruments. And for example, if you even want to take measurements in maybe random order, that can help reduce some measurement bias. Non-response bias was something that we saw in this example because only 2.4 million out of the 10 million people actually responded. This one's tricky also to try to avoid. Some tips are to keep your survey short and be persistent. You can try to have some protocols like of following up to encourage participation to help reduce non-response bias. Now, you may be thinking, well, yeah, this was an election that happened a long time ago, and we're much more sophisticated in our surveying techniques, and so we wouldn't have these bias problems today. I'm going to remind you of the not so long ago 2016 US presidential election, in which nearly all voter polls leading up to the election predicted that Clinton would be a winner over Trump, and Trump's upset victory came as a surprise. After that election, many polling experts were trying to figure out where things had gone wrong. And the American Association for Public Opinion Research actually found that the predictions were flawed for two key reasons. The first was non-response bias. It turns out that college-educated voters were more likely to respond and thus were overrepresented. And at the time, they were more likely to support Clinton. The other source of bias was actually this response bias. And that was because many voters were either undecided or changed their preferences a few days before the election. And, since a poll is static and can only directly measure current beliefs, it wasn't able to reflect this shift in attitudes. It is difficult to try to figure out what type of bias is affecting the results. Exit polls are one way of trying to analyze this, and this did help polling experts understand what happened after the fact. Especially in the 2016 election, exit polls indicated that in battleground states like Michigan, many voters ended up making their choice in the final week of the campaign. And in that example, that group went for Trump by a wide margin. In the next video, we're going to look at how we can use specific sampling techniques to A, try to minimize some selection bias, and B, be able to quantify the chance error that will still exist in the sampling process.